In this lesson, we are going to graph reflections of an object. Okay, let's start with some vocabulary. First, what is a reflection? It's a transformation where the perpendicular distance from the axis of reflection is equal. Okay, so we'll get to that here in a second. But reflections, they're a form of symmetry. Okay, what is an axis of reflection? It's a line that is equidistant from an image and its preimage. So essentially, it's a line that is right in between an image and preimage. A axis of reflection is also known as a line of reflection or an axis of symmetry. And it looks something like this. So if we have our preimage up in the top left corner, our image is in the bottom right corner. So the image is reflected across the axis of reflection to create our image. The distance from A to the axis of reflection is the same as A prime to the axis of reflection. And each of those other 3 points are the same distance. And it is a perpendicular distance. So I could draw a line that goes from A to A prime, and it would cross the axis of reflection at a 90-degree angle. Okay, so let's look at the rules for reflection. Now these are 5 common reflection types across the y-axis, y equals x, y equals negative x, and across the origin. And each of these, the preimage, we're going to say is some point x, y. So when it crosses the x-axis, all I have to do is make the y negative. That's all I'm doing. When I reflect across the y-axis, I just make the x negative. I don't change anything, just make the numbers opposite. Okay. Now when it comes to the crossing y equals x, I actually just flip the coordinates. That's all. When it's y equals negative x, we'll flip the coordinates and make them both negative. And it will sometimes get confused with crossing the origin, in which case we just make both coordinates negative, but we don't flip them. So these two are very close to each other, but one flips, the other doesn't. Okay, and I have an example that we'll take a look at these 5 in more detail. So just know that we can reflect other lines or over other lines. However, these are the most common reflections. If you want to reflect over another line, you're going to need to use the definition of reflection, which is that perpendicular distance from the preimage to the image. Okay, we'll also take a look at that. In our first example, we are going to reflect the triangle ABC across the line x equals 2. So what we want to do is we want to find the perpendicular distance from A to the line. What this will do is this allows us to essentially create a mirror image on the other side of that line. So if A is right here, it's 1 unit away because each of these represents a half unit. So A prime is going to be 1 unit away over here. Or if you want to, 1, 2, 1, 2, it'll be over here. B is the same way because it's directly below A. So B prime would be right over here. C prime, now that was going to be a little further away. C is right here, so it's 1, 2, 3, 4, 5, 6 grid spaces away. So 1, 2, 3, 4, 5, 6 grid spaces away. So it's technically 3 units away to right here. So it's going to look something like this when we draw it in. And you'll notice it looks like I could just crease it directly on that line and they would fold over each other perfectly. Alright, in this example, what we want to do is take the point 1, 2 and and I'm going to reflect it across all the different common axes of reflection that we have. So for all 5, I'm going to use 1, 2 as the preimage. Now if I want to reflect it across the x-axis, the rule is that I'm going to keep the x the same and change the y to the opposite sign. So if my x is 1, then I'm going to have 1, comma. My y is 2, opposite of that is negative 2. So my image is 1, negative 2. And I'm going to follow these rules for the other 4 axes. So when it comes to the y-axis, I'm just going to change the x coordinates to negative and keep the y the same. Okay? For y equals x, I'm actually just going to flip the 2 coordinates. So I'm not changing anything to positive or negative. I'm just flipping the x and the y position. So I get 2, 1 instead of 1, 2. Now when it comes to y equals negative x, I need to do the same thing, but I'm going to make both of them the opposite sign. So in this case, it's negative 2, negative 1. And then across the origin, I'm not switching them, but I'm going to make both of them negative. So negative 1, comma, negative 2. All right, so let's take a look at a couple of visuals. So we have point A right here at 2 or at 1, 2. So I'm going to show you a visual of each of those reflections. So the first one we did was across the x-axis. So it's now down here. So it didn't move left or right any, just moved down. Now I'm going to look at when I went across the y-axis. I didn't go up or down any, I just went to the opposite side. Alright, now with y equals x, it's this line, and it actually flips over it, kind of folds over it. You'll notice that it's directly across from that square. Okay, now if it was y equals negative x, it flips across here. So I'm going to turn off the others, that way you can kind of get a visual. It goes this direction. And you'll notice that it's 3 and 3. Okay, so now when it comes to the origin, it's there. Now I want you to see how close it is. The green is the y equals negative x, and the orange is across the origin. So you can see why it would be important to remember the difference between the two, because they're really close. Alright, in our last example, what we're going to do is reflect the triangle DEF across the line y equals negative x, given that D, E, and F have the following coordinates. Now, before I begin, I want you to take a moment, pause this video, and try this out yourself. Alright, so let's go ahead and talk about this. The rule for the reflecting across this line is that we're going to flip and make both negative. Alright, so if D is at negative 1, 1, I'm going to flip them. Alright, so this is going to be kind of a two-step thing here. So I'm going to flip, so I get 1, negative 1, and then I make opposite, so that turns it into negative 1, 1. So really it doesn't move anywhere. It's the same coordinate. Alright, so now I want to do the same thing with negative 3, negative 3. Well, if I flip them around, it doesn't change. But when I make them the opposite sign, that is going to change it to 3, 3. Okay. Now, lastly, 1, negative 5, I flipped it around, so I'm going to come over here. Negative 5, 1. And then it's going to turn into the opposite, so it's going to be 5, negative 1, like so. So my answer is 5, -1. Now, let's take a look at what this looks like on a coordinate plane. Alright, so here we see the triangle DEF graphed, and then I have the line y equals -x. So I'm going to input the coordinates and graph what we have. So the preimage is here in orange, and the image is here in green. So notice how D and D prime are actually the exact same point. And if I was to draw a line from E to E prime, it would be perpendicular with this line. Same with F and F prime.